the principal here, and I'm sure that you know that. I is talking on a microphone even though we don't need to, because you don't think we need to?
I don't think so.
Because we wanted to record this. Same thing. We wanted to record this for parents who weren't able to come. And there'll be a point when we're recording it. Actually, this is Nico and his dad who are just helping us out. But there'll be a point when maybe some answers will be discussed. And so we will cut the video feed so that we can put it up online without any students getting any answers. So it is so early in the school year, and already you have devoted an evening and like lost family time to come here, and we appreciate that. I feel like there's such a small group of us here that it would be most important to me to feel like I know who you are or what you're feeling before we begin. And I know it's a large group, so I'm going to ask for you to introduce yourself and what child you have, and then tell us, and you have to do it fast, tell us either something that your child felt in the first couple weeks, or generally how it is for them, or something that they said that was funny, or something. Give us just a flashpoint of some response you've gotten from your child being at middle school for the first couple weeks. And before you do that, I'm going to introduce your real presenters tonight, which is Carrie Noble, who is our math department chair, which is a great honor out of 2 math teachers. Carrie is one of our school founders. She and Mr. McCurry were the 2 full-time teachers that opened our school. And it's amazing because they have so many credentials. Ms. Noble has her math single subject, which is her first love, science single subject, and multiple subject credential, and has worked at Newcomb before this and a few other places in Long Beach, and has 3 boys who have gone through the Long Beach school process. So she's been a resource to us in so many ways, but loves math. And I repeat this, you might have heard it before, so I apologize if you have. But what I remember when we were interviewing for math teachers at the very beginning, she talked about the elegance and beauty of math in a way that was so real and vibrant that it changed the way I thought about what math could be. And so that's just like a snapshot of her connection to us based on what I think. And this is Miss Deborah Chen, who is our newest math teacher and completes the math department at IVA. Deborah has taught 3 years before this and been at 2 different middle schools, and so had much varied experiences. She was raised in Long Beach and then went to Modesto and finally was able to come back. And we are so glad that she's a part of us. One of the realizations that she had, or ways that she communicated in our summer professional development that stands out to me the most, is when she said, in the past, I had seen myself as a partner with the parents, and I'm realizing that IVA, I am first a partner with the student. And I had never heard our mission and vision sort of expressed in that way, and so I really appreciate the way that she's been taking her other experiences and melding them with our mission and vision, which she was drawn to in her. So I'm going to let them talk after all of you go so fast tonight that we had this event, and it was a really quick response to some parents saying, I am overwhelmed. There is so much going on. Like navigating technology is one thing, and that is a huge thing, but maybe more substantial is how am I supposed to help with this sort of math? That's why we put 2015, is because it was from last year that we needed to have, just checking, we forgot to change the date. Welcome, and I'm going to turn it over to our math teachers, and it should be interactive. Yay. It should be interactive. Well, you know.
I'm so glad that this table got to share with everybody, because when students come to IVA and take math, a lot of them come and say, I love math, because I'm really fast at it, and then They come to math at IVA, and all of a sudden that foundation is like torn out from underneath them, and they're not sure if they're still as good at math as they thought they once were. And then on the other hand, you have people that like hated math their whole lives, and all of a sudden they're being asked to explain and talk, and they're comfortable with it in a way that they weren't before. So hopefully we can get all of those people appreciating at the same level eventually, but I'm glad that we had both right there. So we're going to talk about first why we do POWs at IVA. Now POWs are the only thing we do. We have regular practice that we do every night, but we also have these month-long projects that we do to try to get them thinking like a mathematician. One of the reasons is thinking like a mathematician. I am reading this article with my 7th graders tomorrow. No, Monday. And this is like what mathematicians are doing right now. And this is what we're learning in 7th grade math on Monday. It's about tiling patterns and how you can put shapes together, polygons together, to tile the floor. And there were only 14 of these. I think they're all pentagons. Am I right? There were only 14 discovered. And then there was this couple, this mathematician couple, who spent years, and they finally found the 15th one. Like, that's what mathematicians do. Like, you now wish you were a mathematician, so you spend years looking for the new shape that would tile the floor. But, like, this is what mathematicians work on, and they don't always know if there's an answer. You know, they worked for years not knowing if they would ever find it. And that is scary, and that is frustrating, but it's immensely satisfying when you finally get there. So we're trying to get them to think about math in this way, as not just a list of steps that you follow, but like solving big problems. We also do POWs because we want them to push beyond their comfort zone a little bit. That's a struggle for the kids that are used to getting the right answer quickly. So we want them to experience a little bit of struggle and hopefully end up with some success, or learn how to deal with it if you don't find it. The other thing is writing up a POW lets us see your thinking instead of just writing the answer. So we want to make that thinking visible. POWs also tie in really, really well to the Common Core math practices standards. Like all 8 of them would work really well. So like, this is the kind of thinking that they want us to be doing. And it's the kind of thinking mathematicians do. So we stand up in that. So that's why we do POWs at IVA. Some people ask how the POWs tie into the curriculum, because sometimes it's not a super clear thing.
Before you go there, would you just, for people that might not have that context, what is a POW? How often is it given? Just those things.
Okay, so about once a month, we assign a project or a POW to students. POWs are different than projects because POWs have a very specific 5-section write-up, which we're going to talk about later. Projects are just what you would imagine. They all vary in a project where you have to just find the half-life of this substance or something, but it doesn't have these 5 write-up sections. The problem of the week format, I think, started like university levels. Like they'll put like the math department will put out a big problem, and then if you've ever seen like Good Will Hunting, I think it's that movie. Is that the one where there's a big math problem on the chalkboard, and then the janitor Matt Damon solves it? Like that would be like a problem of the week in a math department. They only give you a week. We give them a month because we break down each section of the write-up and make sure that they're not procrastinating and have little checkpoints here and there. So we stretch it out, but at the university level, it's called a problem of the week. So
I interrupted you, and you were just about to say how POWs are connected with the overall math curriculum.
Oh yes, thank you. So some of them, for example, like the checkerboard POW that your kids. Wait, who doesn't have a 6th grader? Is there any new 7th and 8th graders? Who do you have?
A little bit the same.
Oh, okay, got it. Yes, I see that. I didn't even have to tell you that. Okay. So you have a new 7th grader.
Yeah.
So he didn't have to do this one. But the checkerboard POW that most of you are doing right now, it's all about number theory. And we don't want to tell them what it's about because that would give away the answer, but it ties into what they're learning in this unit. Just let that. That's just going to be known. I don't think we do have students in here. She's a student this year.
Don't forget.
I'm going to use like my men in black, like memory on. It's about square numbers. So they're going to be learning about squaring numbers, but we don't want to tell them it's about square numbers because that would give away the fun of finding answers on.
Can I add to that?
Yes.
So when we founded the school, we looked at curriculum. There was a committee that looked at curriculum all over the place. And we were only satisfied and so pleased to find fully created, published curriculum in math and science. Everything else we've had to create ourselves. But math and science, they both end up having this inquiry-based type of learning. And science is, you're like a scientist and you're discovering things, not like a project that your teacher knows the answer to. It's an actual question that you do an experiment and find different variant solutions for. And the same thing in math. So math is an inquiry-based curriculum. Would you describe that?
Yeah, so in the regular curriculum that we do every day, instead of, for example, giving them a formula for the area of a triangle, we would like derive that by looking at rectangles and cutting them in half and seeing if half is the same as, the other half. And, we figure it out, and they have to derive their own formulas. So that's like a big difference. They also do a lot of making conjectures, which are like unproven statements. In their 6th grade mind, these statements are unproven. They've been proven. They're conjectures to them, so we call them conjectures, and we put them up on the wall so that we can see what kind of thinking they're done. So that's different than like, I'm going to write the procedure here, you're going to copy it down in your notebook, and then we're going to do 10 practice problems. Like that isn't how we do it. But we do practice problems. I just don't spell out procedures. We figure it out together, and then we practice. Any questions about just the regular? These POWs are things that I've grabbed from various sources that I think tie in nicely to the curriculum. The projects usually come straight from the curriculum. So if there's a project in the book I really like, that month we do the project from the book. If there's a project in the book that I'm like, no, I think this POW would be better, we do a POW instead. So that's how that happens. So sometimes it's connected directly to the curriculum. Sometimes it's something that I want them to explore on their own before we get to the unit on that topic. So 8th graders are doing Pythagorean theorem projects right now, and the unit's next month. So they're going to be ready to jump right into Pythagorean theorems. They would have explored this on their own a little bit. So that's how we choose the projects. Let me see. When you do a POW, there are 5 sections. I'm going to tell you a little bit about each section and why they're important and how we grade them. Okay? The problem statement is, you probably already signed. You're on process. Okay, so the problem statement, they just have to rewrite the problem in their own words. And the whole purpose of that is just to make sure they understand the problem well enough to explain it to somebody else. Because if I'm grading their paper later when they're done, and I feel like they're answering the wrong question, I can look back to their problem statement and see if they made an error there. And if maybe they're answering a different question altogether because they weren't able to figure out how to translate this question in their own words. For this one, for the problem statement section, that's an easy one for parents to read over and see if what was written on the original paper matches, at least in number sense, what they wrote, right? They can change the story. So in 7th grade, we were doing one on a king who has 8 bags of gold, and he gives it to his 8 trusty people in the town, and he's heard that somebody's been using some of his gold. So he brings it back, and he has to figure out which bag's the lightest, using only a pan balance as few times as possible, right? So I had a new student, I was excited because he was a new 7th grader. He did his problem statement about baseball cards in a bag, and somebody had traded a baseball card. He changed the story, but it still had the same, like, there are 8 bags of things in there. So they can be creative and change the context, but the math has to be the same. So that's kind of fun. The process section is the meat of the paper. And that's where they're supposed to write everything they did, even if it was wrong, when they were trying to solve this problem. And that's where we really get to see their thinking. So if, well, I'll get to the, well, we can talk about the checkerboard one. Have you all seen the checkerboard one, except for maybe Logan's dad? Is there anybody who hasn't seen the checkerboard one? You haven't. Okay. Here's the checkerboard problem. It says Jeff and Ali got tired of playing checkers one day and started to look at the checkerboard instead. They were trying to figure out how many squares were on the checkerboard, and they could not agree on an answer. How many squares do you think are on the checkerboard? So a student who was looking at this, the first thing they might write, what do you think the first thing they might write?
8 times 8 is 64.
Thank you. The first thing they're going to say is, I got started on this right away. I know the answer is 64. Done.